Hey guys, so I wanted to give you some information on atomic structure because that is our next unit. So let's get it, let's go. Alright, so we talked about the differences between an atom, an element, a compound, and a molecule. So most of this is going to be review. So the atom is going to be the smallest particle of matter that retains the property of that element. Okay. There are a few videos that I'm going to have you guys take a look at, and they're right down here. What I want you to know in terms of atomic structure, atoms are going to be composed of 3 subatomic particles. The 3 subatomic particles, this should be a review from the PhET that you guys did yesterday. They are going to be the electron, the proton, and the neutron. For the electron, there is virtually no mass. Its charge is going to be negative. For your proton, it's going to be basically what we call 1 atomic mass unit. That will come more into play a little bit later on. And then just know that it has a positive charge. We have neutron. Neutron, we're going to put the mass down as 1 AMU. It is slightly bigger or more massive than a proton, and then its charge is going to be neutral. Now, what I mean by neutral in terms of atomic structure, that means that the number of electrons must equal the number of protons. And then, of course, you guys should have learned from your PhET that the identity of the atom is going to be based on the number of protons. So if you look at the periodic table and you have an element that has proton number 1, that's going to be hydrogen. Okay, if it has a proton number of 4, take a look at your periodic table. Mine's up here on the wall. That would be beryllium, all right? But it's the proton that's going to determine what atom or element that we are talking about. Okay, so some terms that I want you guys to know. When atoms of the same element contain different number of neutrons, they are called isotopes. In general, a neutral atom has an overall charge of 0. And when an atom loses or gains an electron, that's when an ion gets formed. So there are 2 different types of ions that I want you guys to know about. It's the cation. So the cation is going to form when the atom loses electrons. Okay? And then you'll see these terminology here. Okay? Positive VE charge. Okay? That's just going to be a valence electron. Okay? So you just need to know that when an atom loses an electron, you form an ion with a positive charge. Okay, in terms of an anion, this is going to form when an atom gains an electron, meaning that it's going to add a valence electron, it's going to add a negative charge because, like in the first slide we talked about, electrons are negatively charged. So, really important, right? We are going to be talking about this probably for maybe a couple of months. So, valence electrons are going to be the electrons that are in the outermost energy level. So if we take a look at the way atomic structure is, right? So if we go over here, some of these things are a review. So we have the nucleus is going to contain protons. They're usually represented with a P with a plus on the top, and then neutrons just has an N. And basically it's going to tell you or characterize the mass of an atom. So if we take a look at our atomic structure and what we would call our electron cloud, which is the region of the nucleus where the electrons are moving, okay, that's going to characterize the volume or how wide that particular atom is. So if we take a look at all the different energy shells, we have a first, second, third, and fourth energy shell, and they contain a certain amount of electrons. So in the first energy level, it contains 2 electrons. In the second energy level, we're now up to 8 electrons. And then up in the third is 18 electrons, and then the fourth is going to be 32 electrons. This will come more in play when we start doing electron configurations and we start drawing some representations of what atoms look like. Okay, so the big thing for atomic structure is just notation, right? So in terms of trying to understand your periodic table is going to have 3 major important pieces, and you're going to need to know how to find them and what they are. So the first one is going to be up here at the top. And if you look here, we have carbon. is the element that we decided to pick. But if you look up here, up top, this number in red represents the atomic number. And the atomic number is going to represent the number of protons in the nucleus, okay? And if it is a neutral atom, it's also going to equal the number of electrons. Okay, so that's a big thing to remember. The number of protons is going to equal the number of electrons. The second, in a neutral atom, let me be clear. If you have an ion, this may be different. Okay, so here is going to be our chemical symbol. Every element is going to be represented by its own chemical symbol. In carbon's case, it is an upper letter C. This is going to be the abbreviation or the name of the element. If there is only one number, no, that's a letter. If it only has one number, that first letter is going to be capital. If it does have two, like for example, iron is Fe, that's capital F, lowercase e. Okay, so if it does have a second letter, then it's always going to be lowercase. And if you look down here at the bottom, this is average atomic mass. We're going to talk about this a little bit more. You guys will be doing an activity, a lab on Monday that's going to have to deal with average atomic mass. Basically, average atomic mass is going to be the average mass of the mixtures of all the isotopes. So, for example, for carbon, there are several different isotopes. There's carbon-12, there's carbon-14. Basically, what they did is they took all of the carbon in the whole universe, right, and figured out what its average atomic mass is, and then came up with a number. Okay, so this number on the bottom is going to represent average atomic mass. A little bit later on, we will recognize that as grams per mole, and we will be using it for some of our calculations. Okay, so hopefully that was, well, most of it should have been a review, and hopefully that clarifies some of your some of the items that you had to do in your PhET, and hopefully that was helpful.